Hello, my name is William Kirkendall, Team Leader for Field Applications Engineering here at Reaction Design. Welcome to this video about FORTÉ and knock prediction for SI engines. In this video, I will walk you through how to set up a FORTÉ simulation to predict knock in an SI engine.
In the past, using detailed chemistry in CFD was unfeasible, but with today's computing power and advanced CFD tools like FORTÉ, using detailed chemistry in CFD simulations is not only feasible, it is a requirement to get accurate CFD predictions. Let's take a closer look at the conditions for this engine simulation. This example case is a port-injected, spark-ignited engine where we consider the fuel to be pre-mixed and pre-vaporized, but we could have modeled the injection event in the port or into the cylinder if this were a GDI engine. Now let's take a look at the engine setup in FORTÉ. We want to model a gasoline fuel in this engine, and the chemistry should be able to predict knocking in the engine. Within FORTÉ, there's several chemistry mechanisms available depending on the type of fuel of interest. In this case, we're going to use a primary reference fuel mechanism that has 178 species and allows us to look at different octane numbers of the fuel. A primary reference fuel contains isooctane and N-heptane as the fuel components. Since this is a spark-ignited engine, the spark ignition model should be activated in FORTÉ. This is where we'll specify the spark location, starting angle, and duration of the spark event. You can also add parameter studies for FORTÉ inputs such as spark timing. FORTÉ has ChemCan Pro built inside. In addition to the ChemCan Pro chemistry solver built into FORTÉ, FORTÉ has some unique capabilities to speed up the chemistry solution even more. Dynamic adaptive chemistry performs a mechanism reduction on the fly, which means FORTÉ uses only the amount of chemistry required for a particular time step. This option is typically only used with very large chemistry mechanisms of 500 or more species, since the base ChemCan Pro solver built into FORTÉ is already very fast. The other unique capability is the dynamic cell clustering, which is used for all reacting flow simulations. This option will cluster together cells that are kinetically similar based on temperature and equivalence ratio dispersion. In FORTÉ, you can add monitor points so that you can sample the data at a specific location inside the engine. In this case, we've added a monitor point under the intake valves, near the spark plug and the exhaust valves. We want to monitor the pressure at these locations so that we can determine where in the engine we may have knocking occurring. We can then take these pressure curves and pass them through a bandpass filter in the FORTÉ visualizer to determine a knocking index. Let's take a look at the results in the FORTÉ visualizer. So I've read in the results and created a plot of the pressure versus the crank angle, and I've also applied a bandpass filter to this pressure trace, which will allow me to calculate a knocking index, which assesses how much an engine is knocking so that you can compare different engine conditions with a single number like the knocking index. Now that we've determined this engine is indeed knocking and we've computed a knocking index, we could take a look at the 3D results to see where is the engine knocking. What you see here is a cut plane just below the head through the piston at 710 crank angles, 10 degrees before top dead center. On the mesh cut plane, there where the white and black mesh intersect, this is the location of the flame front. So this is where the flame front resides at this point in time. The contour map you see is the temperature. So we can see where the flame is currently positioned in the engine, and what we should see is cool gas ahead of the flame front, since the flame front has not yet passed it. However, we see that the end gas is already auto-ignited and burned ahead of the flame front. This indicates that we have knocking in the engine. So we could now take a deeper look and try to understand why this engine condition is knocking, and we could do some further analysis in the FORTÉ visualizer. That completes this video on how better chemistry and fuel surrogates allow you to predict knocking in an SI engine using FORTÉ. Thank you for viewing this video. If you have any questions or comments, please feel free to contact Reaction Design by emailing sales@reactiondesign.com for more information. You can always find us on the web at www.reactiondesign.com. We encourage you to check back our website as we will continue to upload additional videos. We look forward to helping you with your simulation needs. Thank you.